Okay, hello everyone. Good morning.
Good morning, sir.
Morning. Yeah, am I audible?
Yes, yes.
Thank you. Okay, so in the last lecture, we had completed the portion of roots of equation. The three method we have learned to predict the root of any types of equations by using bisection, regular policy, and Newton-Raphson method. Okay, and after that, we had started the second part of this unit, that is the interpolation theory. And we had discussed its meaning in the last lecture. What is meaning of interpolation and which type of formula we'll use to predict the answer. Okay, so interpolation is nothing but to process of computing intermediate values of a functions from a given set of a table. Okay, tabulator value of any function. Okay, so we can predict any intermediate value and its output. Okay, by using the interpolation technique. And after that, to derive this formula, we'll first learn uh, some simple operator that is known as a finite difference operator. So first one that was discussed is a delta. Okay, delta that is known as a forward difference operator. And for equally spaced data in this table, we can consider delta fx, that will be the f of x plus h minus fx, or that is the formula of forward difference operator. And that is the number line is given here. If we add such value x h to this value x, so here we get x plus h form, and subtract the h from this x, you will get a x minus h. Okay, and then after we apply the delta to this fx value, so it will be the f of x plus h minus the fx. Okay, that is the first one. And then after second, that is the NEMLA, that is known as a backward difference operator, and that is denoted as a for equally spaced data, it will be defined as a NEMLA fx is equal to fx minus f of x minus h. Okay, you have to shift to the backward side. Okay, that is x minus h fx. Okay, so it is known as a backward shifting, backward difference operator. And delta fx, that is known as a sorry, NEMLA fx, that is known as a fx minus f of x minus h. And after that, that is third one was the shifting operator, that is denoted by e, and it is defined as a e raised to an fx. Okay, you have to shift as per the power. Okay, if it is power 1, means the power of e, that is a 1, then you have to shift to the one step. Okay, to the forward side. If it is positive, then we'll shift to the forward side, and if it is negative, then we'll shift to the negative side. Okay, backward side means if we have e raised to minus 2 fx, then it will be the f of x minus 2x. Okay, you have to shift to the backward side in this line. And after that, first one was there a difference operator, a simple one, a derivative operator, a dfx, that is known as a d by dx fx, and it is also known as f dash x. Okay, it is simple one, difference operator. And after that, we discuss the two relations. Okay, uh, relations between all such operator. So first one that was discussed, that is e is equal to 1 plus NEMLA. Okay, that we was discussed in the last lecture. And how we can prove that, that is the proof of this one. Just we are using the formulas. Okay, we are using this formula here, 1 plus NEMLA fx, that is equal to apply fx to the inside, and then after 1 plus delta fx formula, that is f of x plus h minus fx, then fx minus fx will be removed there, so it will be the f of x plus h form. And now apply the shifting formula here. So f of x plus h means you have to shift to the one step, so power of e will be 1 that, so e1 fx, that is f of x plus h, and e with power 1, that is right as the efx only. And now we can define as the 1 plus NEMLA, 1 plus delta is equal to e. Okay, so first one. And after that, I will discuss the second one. E NEMLA is equal to delta. Okay, e NEMLA is equal to delta, that was discussed in the last lecture, and that is also simple. First, consider any one operator to the inside. Okay, start with the e nemla for any function fx. So it will be the e of nemla fx, and write a formula of nemla fx. So it is fx minus f of x minus h. Clear? That is e fx minus e f of x minus h. Clear? First, we put here formula nemla fx formula fx minus f of x minus h, and then after apply e to the inside, and now we'll use the formula of EFX. Okay, so EFX will be the f of x plus h. Okay, that is are given in such form now. Okay, that is x here. That is x plus h, and here it is x minus h. Okay, this value is x minus h, and x plus 2h, and so on. Okay, and now we apply the e to this fx value. Okay, output of the function at x. So we'll get f of x plus h. Okay, that is answer. You have to shift to the one step to the forward side, and here it is e f of x minus h. Okay, you are at the place x minus h, and you are applying the e operator to the f of x minus h. So what is the next output after the x minus h? So it will be the x here. So we will get f of x for the answer of e of f of x minus h. Okay, you will get here f of x because we are applying the shifting operator at x minus h value. Okay, so what will be the output after the x minus h? So that will be the fx output, that okay, function's value at x, so it is known as fx. So you'll get a fx here. Okay, and you are applying the e to the x, so you'll get x plus h. If you are applying the e to the x minus h plus, you will get the fx. Okay, and so on. So it is the f of x plus h minus fx. And what is the formula of f of x plus h minus fx? That is a delta fx. So thus consider for every functions we can write e nemla is equal to a delta. Okay, for any functions you can prove this. And now the third one is there. Prove that delta into nemla is equal to delta minus nemla. Okay, so let us first prove it. Let's start with the delta into nemla fx. Okay, so apply any operator to the inside. So first step, it will be delta of nemla fx. Okay, this is the first step. And now write a formula of nemla fx. So formula of nemla fx that we have fx minus f of x minus h. Okay, that is fx minus f of x minus h, and now apply delta to this both term. So it will be a delta fx. Okay, a minus delta of f of x minus h. This term you will get after that. Okay, and now delta fx consider as it is here as the first term, and here write formula of delta of f of x minus h, and that is important for us. Okay, how we can create this formula? We are applying delta to the x minus h plus. Okay, this is a number line we have for equally spaced data, that is x plus h. Okay, and here it is x minus h. Now, if you are creating the formula of delta fx, so what is output of delta fx? That will be the next value. Next value we have x plus h. Okay, so it will be the f of x plus h minus the fx. Okay, that is the formula of delta fx. And now we are applying a delta operator to the place x minus h. Okay, we are applying delta to this place here. So what will be its output? The next value. What will be the next value after the x minus h form? So it will be the fx here. Okay, the function output at x minus f of x minus h. Okay, so delta fx that we have f of x plus h minus fx. Okay, you will get this output minus fx output. So now we are applying for this case a delta operator to the place x minus h. Okay, to the point x minus h. So what will be output as per the delta definition? So it will be delta fx minus f of x minus h. Okay, it is fx minus f of x minus. That is the output of delta f of x minus h. Okay, so just write down it here. Now that is delta fx minus in the bracket fx minus f of x minus h. Okay, and now what is meaning of this one? That is a formula of nemla fx. Okay, that is the formula of nemla fx. So write down it here. So it is a delta fx, the first term, and from the second bracket, okay, from this bracket we can write nemla fx, okay. And now consider fx common from this both, so it will be delta minus nemla fx, okay. And now for every functions we can write delta into nemla fx, that is equal to delta minus nemla fx, okay. And that will be delta into nemla is equal to delta minus nemla. Is it clear to all? Have you any query in this any step?
No, sir.
Remaining student, have you any doubt in any step? So ask me now. Is it clear to all? Is there any doubt in any step? Because not only this result is important, proof is also important for us, okay?
Sir, can you repeat the delta f of x minus fx minus f third step?
Yeah,
Third
okay.
step.
So
Third
here,
step.
yeah. So here in this first step, okay, let's start with the first step, a delta of a nemla fx, okay. So in the second step, we just put the formula of nemla fx, okay, nemla fx, that is fx minus f of x minus h, okay. And after
Yes.
that, apply delta to this both term. So it will be delta fx minus delta f of x minus h, okay. And after delta fx, consider as it is here, and now we are putting the formula of delta f of x minus h, okay, that you have to create. वो हमें create करना है, ठीक है. We have not any direct formula for that. So how we can create this formula as per the rules of delta operator? So here we know that formula of delta fx, okay, in this line, just consider here value x, that is our central value, and after h, add h value to this x, so we'll get x plus h here, okay, and subtract h from this x, so we'll get x minus h here, okay. And
Yes.
now formula of delta fx, so what is the rule of delta fx? You will get the next output, okay, that is f of x plus h output minus fx output, okay, next value minus the as it is value that you have to predict. So it is a f of x plus h minus fx, okay, that is the formula of delta fx. What is the rule? Consider next output, okay, minus the fx output. And now we are applying delta, okay, हम delta कहाँ पे apply कर रहे हैं? At the place x minus h पे आप apply कर रहे हो delta, okay. So what will be the rule of delta? You predict the next output. Next output क्या होगा? X minus h plus h. That will be the f of x. That will be the next output at that case, okay. So it is a fx minus uh, f of x minus h, okay. You are applying delta to the place x minus h, so it will be the fx minus f of x minus h.
But sir, in third step, in bracket f of x minus f. Yes, I don't understand how to predict it. How?
Yes. Thus here we apply the formula of delta f of x minus h only, okay. If we have this formula of delta fx हम कैसे predict करते हैं? It will be the f of x plus h, that is the next output after the x, okay. Next output after the x क्या है? That is x plus h minus the fx, okay. The output at the place x. We are applying delta to the place x now, okay. So output of it will be f of x plus h minus fx. अब आप delta x minus h पे apply कर रहे हो, ठीक है. You are applying delta at the place x minus h, यहाँ पे आप apply कर रहे हो, तो इसका output क्या होगा? तो नेक्स्ट आउटपुट क्या है? दैट इज नेक्स्ट वैल्यू क्या है? x माइनस h के बाद तो x है, ठीक है. तो यहाँ पे एफ एक्स डिफाइन होगा और x माइनस h पे क्या डिफाइन होगा? दैट इज f of x माइनस h, इसका डिफरेंस. सो इट विल बी द f x माइनस f of x माइनस h.
Okay.
Is it clear?
Yes, sir. Now.
Okay, good. So then after now check this bracket, okay. हमें जो वैल्यू डी आई की है डेल्टा फॉर्मूला से, that will be the fx minus f of x minus h. So it is the formula of nemla also, okay. In this formula of nemla fx, how we can define the nemla formula? That is also same, fx minus f of x minus h, okay. So in place of this bracket we can put a nemla fx, okay. So in this fourth step I just put a nemla fx value in place of this bracket, ठीक है, क्योंकि ये जो डिफाइन हुआ है फॉर्मूला, दैट इज आल्सो द फॉर्मूला ऑफ नेमला fx, okay. So that is delta fx minus nemla fx. Now consider fx is the common, okay. So it will be delta minus nemla. And now remove the fx for every fx. So it will be delta nembla is equal to delta minus nembla. Yes. Is it clear to all now? Any query?
No, sir.
Okay. Good. Okay, so it is a third one. Now this type of questions ask for a MCQ type. Okay. Okay. Which of the following result is the correct one? Delta nembla is equal to which of the following option is the correct one? Okay. So this is asked for 1 mark MCQ. Otherwise, uh, a 2 to 4 marks questions that. Okay. If we combine the two result as a 4 mark theory. Okay. Okay. Prove that following result. So proof is also important for us. Okay. So remember also this each and every step how we can prove this. And this result is also important for 1 mark short questions and 1 mark MCQ. Now after that, we'll add some more result, that is the relation of delta and nembla. I think that result we had discussed in the first lecture, but let's repeat this. Relation of nembla and E. Okay, relation of nembla and E that we have here. Nembla is equal to 1 minus E inverse. Okay, that is the relations between nembla and E. And we have relation of E and delta, that is the E is equal to 1 plus delta. Okay, that we have discussed as the first result uh, in this topic. Okay, E is equal to 1 plus delta. That is the relations of E and delta. Okay, that we already proved. And now that is the relation of nembla and E. That is nembla is equal to 1 minus E inverse. Okay, why it is uh, true here? Let us check that. Okay, so let us start with the nembla fx formula. So nembla fx is equal to fx minus f of x minus h. This is the formula of nembla fx. Okay, and now fx consider as it is here. And now in place of f of x minus h, we have the rule of a shifting operator. If we have efx, then it will be the f of x plus h. Okay, power of e, that is now 1 here. If it is a e raised to 2, then it will be the e of f of x plus 2h. Okay, so now we have x minus h form. Okay, in this step. So in place of x minus h, we can put e raised to minus 1 fx. So it will be the f of x minus h. Okay, you have to shift backward side as the one step. Okay, e raised to minus 1 fx, that is equal to f of x minus h. Okay, so in place of f of x minus h, we can put e raised to minus 1 fx. Okay, and now take fx as a common, so it will be the e raised to minus 1 fx. Okay, and that we have nembla fx. So for every fx, we can write nembla is equal to 1 minus e inverse. Okay, nembla is equal to 1 minus e. That is the relations between nembla and e. Okay, what is the relations of nembla and e? That is the nembla is equal to 1 minus e inverse, and this is the relations of e and delta. Okay, delta and e, that is e is equal to 1 plus delta. Okay, so this is also important. And now based on this result, both the result will define one formula, that is equal to 1 plus delta and 1 minus nembla, that is equal to 1. Okay, 1 plus delta answer into 1 minus nembla, that will be the 1. Okay, and how we can prove it? So we have two result. Okay, which two result? E is equal to 1 plus a delta. Okay, that is a first result that we had already discussed. And now second that we discuss right now, that is nembla is equal to 1 minus E inverse. Okay, 1 minus E inverse, and now we need 1 minus nembla form. So it will be E inverse is equal to, thus we simplify that one. Okay, we need 1 minus nembla from this result. Okay, so you can shift a nembla to this side and minus E inverse to this side. So it will be the plus E inverse here, and this equal to, now shift nembla, okay, to this side. So it will be the 1 minus a nembla. Clear? We just interchange this both term. Here negative E inverse, so it will be shift to this side, and here nembla will be shift to this side. Okay, just interchange this. So it will be negative here, and that negative will convert to the positive. So that is second result. E inverse is equal to 1 minus nembla, and E is equal to 1 plus delta. So use this in this form. So 1 minus delta into 1 minus nembla. So it will become 1 minus lambda is the E, okay, into 1 minus lambda is equal to minus E inverse. Okay, so E into E inverse, that will form E raised to 0, and E raised to 0 is equal to 1. Okay, as any form, any constant term, any x with the power 0, okay, that we know that 1. It is meaning of the x raised to 0. Clear? 1 raised to 0, 2 raised to 0, 3 raised to 0. So that is the 1 as we know. Clear? So e raised to 0 is equal to 1. So prove ho gaya 1 plus delta into 1 minus lambda, that is equal to 1. Okay, by using this both result you can prove that. And it is also important for 1 mark short question and 1 mark MCQ. क्लियर? सिंपली है, जस्ट दो फॉर्मूला में यूज करनी है, एक ई की और एक नेमला की. ओके, ई इज इक्वल टू 1 plus delta and e inverse is equal to 1 minus lambda. Use this both and replace it here, so it will become e into e minus 1 and e into e minus 1 will become e raised to 0. okay, पावर का एडिशन होगा वहां पे. यहाँ पे e की पावर 1 है and there is a minus 1 power, so it will be the e raised to 1 minus 1 and that become e raised to 0, and e raised to 0 is equal to 1. okay, so that is a simple result. And now let's discuss the last one. That is the E is equal to e raised to hd. Okay, that is a relation between a shifting operator E and the difference operator D. Okay, that is the relation between shifting operator E and a difference operator D. E is equal to e raised to hd. And how we can prove that? Let us discuss. Okay, we have the EFX. Okay, the shifting operator E. Okay, apply e to the fx, e with the power 1 is here, so it will become e of f of x plus h. Okay, the efx will be the f of x plus h. You will get a next output at the x, so it is f of x plus h. And now to creating the exponential form, okay, we'll define one a sequence, we'll define one a series. Okay, that is a Taylor series form of the f of x plus h. Okay, so it is one series of f of x plus h function, and that is called a Taylor expansion, Taylor series. Okay, so how we can define that? First term will be the fx, and then after involve its derivative one by one. Okay, first time derivative, second time derivative, third time derivative, and so on. So fx plus h into f dash x plus h square by 2 factorial f double dash x plus h cube by 3 factorial f triple dash x, and so on. Okay, it is a Taylor series expansion of the form of the function f of x plus h. Okay, this is required to define the exponential form. Okay, so fx plus h into f dash x plus h square by 2 factorial f double dash x plus h cube by 3 factorial f triple dash x, and so on. Okay, it is a simple Taylor series form of the f of x plus h. And now will convert the derivative, this f dash x form, to the d form. Okay, d by dx form. So here we'll replace the derivative, means f dash x will be the dfx form. Okay, that is another form of the derivative, d by dx, otherwise dfx, that is known as a d by dx fx. Okay, and that is also known as f dash x. Clear? If it is a 2 times derivative, then we consider d square fx, and it will be the d2 by dx2 fx. Okay, and that is also known as a f double dash fx. Clear? That is also known as a f double dash fx, and so on. So just replace a derivative by the d fx form. Okay, so f dash x one time derivative only, so it will be replaced by dfx. Okay, and here fx as it is, the first term will be as it is that, because it is not a derivative form. Okay, it is a simple form, simple function. And here from the second term, that is a h into f dash x, so it will be replaced by dfx. Okay, so h as it is here, and f dash x will be replaced by a dfx. That is meaning is same that. Okay, just we need a d notations here in the formula in this equation, therefore we are replacing that. So f dash x, that is a dfx, then after next term, that is h square by 2 factorial, and it is a f double dash x is given. Okay, f double dash x, so it will be the d square fx. Clear? That is a d square fx, because they are 2 times derivative. And then after, if we require third term, then h cube by 3 factorial, यहाँ पे क्या define होगा? d cube fx. Okay, that is a f triple dash x, so it will be the 3 time derivative with respect to x, so it is a d cube fx, and so on. Okay, And after that, we'll consider fx common. Okay, we'll take the fx common from this step. So identify means take fx common. From the first term, remaining term will be 1. From the second term, consider fx is a common. So the remaining term is h into d. Okay, that is hd. Then after h square by 2 factorial, consider fx common from the third term. So remaining is a h square d square by 2 factorial. Then from the next term, remaining is a h cube d cube by 3 factorial, and so on. Bracket over and write the fx outside. Okay, so we just take fx common from this step. Okay, and remaining form of this series that I define in the bracket. Okay, h plus 1 plus hd plus h square d square 2 factorial plus h cube d cube 3 factorial up to so on, bracket over fx. Okay, and now we are using the e raised to x series. Okay, so what is the formation of e raised to x series? That is in such form. E raised to x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial, and so on. It is expansion of e raised to x. Okay, that is one result we have in mathematics, e raised to x series. That is 1 plus x square by 2 factorial plus x cube by 3 factorial, and so on. Okay, so we are using this result to create e raised to hd form. Okay, just compare this bracket with this series. So it is a 1 plus x square by 2 factorial plus x cube by 3 factorial, and so on. So in place of x, we have h into d. In place of x, we have h into d. So just compare with this 1 plus hd plus h squared d square by 2 factorial plus h cube d cube by 3 factorial plus up to so on. Okay, so it is one types of expansion form. Okay, one types of e raised to x series form. So we can write e raised to x as a e raised to hd into the fx. Okay, so efx, that is equal to e raised to hd into fx. Okay, just we consider x as a hd in this series, and they are same now. Okay, so that is one expansion of e raised to x, and here it is also a same by putting x is equal to hd in this series. Okay, so we get this form. So we can write in place of this bracket e raised to hd. Okay, so e raised to x is hd, and that is e raised to hd into fx. And then after we can write fx e is equal to e raised to hd. Okay, so it is the relations between e and d. Is it clear? Have you any query? Hello, have you any doubt, any query? Is it clear? Is each and every step?
Yes, sir.
Yes, sir, clear.
Yes, sir. Yes, sir.
Okay, good.
No, no query.
Okay, so these are the relations. Okay, such operators we have to define the interpolations formula. That is a delta, nembla, okay, shifting operator, e, divide operator, difference operator, and based on that we can predict such result. Okay, this result are also important. So just prepare its proof also. Okay, its result five. I think 5 result only we have. Okay, first one relations of e, then after relations of nembla and e, then after delta nembla, e delta, e nembla. That is a simple result we have. So just prepare its proof also. Okay, these all are important for a 1 mark short questions, 1 mark MCQ, and it is also asked for a 2 to 4 mark result. Okay, we can combine both result in one question, then uh, uh, derive the proof of this one. Okay, derive the proof of this both one. So you have to prove by using such mathematical result. Okay, and here we just using one extra result in this last one. Okay, that is a Taylor series and one expansion of e raised to x. Okay, that is one extra form. But in this previous all this result, we are using just formula only. Okay, related to this a given form. There is no any extra thing that we have added. Okay, but here in this last one, we just add one Taylor series expansion and the e raised to x series form to create e raised to hd form. Okay, that is the this extra thing that we have added here. Okay, so next topic, that is the interpolations, and here we'll predict the first formula to define our answer from this table. Okay, so let us first revise what is the meaning of interpolations and how we can evaluate the answer from this tabulated data, and what is meaning of the interpolation. Okay, we'll consider this counter example also to for the interpolation theory. So interpolations is the process, okay, that we already discussed in the starting of this topic. Interpolation is the process of computing intermediate values of a function. Okay, any function you can consider, any mathematical model, any experiment you can consider here. Okay, here we have such input value as the x, x0, x1, x2, x3 up to xn, and its output value for any experiment. Okay, there is y means any function, any mathematical model, any experiment you can consider here, any types of experiment. Okay, so y of x, it is output. At x0 we get y0, x1 it will be y1, x2 it is y2, up to the last one xn we get a y. Okay, so here interpolation is the process of computing intermediate values of functions at y is equal to fx from the given set of tabulated value of the function. Okay, so this type of data are given, and now we have to predict such intermediate value. Okay, for example, there is such value between x0 to x1, and you have to predict it output without doing the experiment again, without using the function, and how we can check this value. Okay, without using this function and without doing the experiment again. Okay, so that in this case we can use such interpolation theory to predict the answer. And here one counter example is given that for the data. Here the population of city is given below. Okay, year wise population is given. Estimate the populations for the year 1898, okay, and 1925 using the suitable interpolation. That we'll discuss later, which will be the suitable for 1898 and 1925. So here one data is given, that one table is given, that for the year wise population at 1891 the populations was there 46,000. Okay, that value 46 means it is in thousand. Okay, then after 1901 the population is 66,000, that is 1911 populations was there 81, 1921 populations was there 93,000, and 1931 that is the 101,000. And now you have to predict, okay, without doing this procedure again, without we have to predict the answer at 1898. Okay, 1898 are in between 1891 and 1901. Okay, this year are in between this two interval, two value. So now you have to predict the answer here. So what will be the possible approximate value that we can consider here? Okay, so how we can predict this value? You have to predict the answer without calculating the population again. Okay, without doing this procedure again. Okay, that we calculate by using such a procedure of calculations. Okay, of the population's growth and so on. So now we have to not doing this thing again. Okay, we have to just calculate this value without doing this experiment again. So how we can check this output? So here we can apply the interpolation theory to predict this answer. Okay, to predict this answer, okay, what will be the possible what will be the approximate populations okay, in this year. Okay, and similarly here it is another year is given there 1925. So we need to predict the answer at 1925. What will be the populations in this 1925 year? Okay, so that we can predict by using interpolation theory. Interpolations, you can use the interpolations formula to predict such approximate answer. What will be the population's growth in this year? Okay, in this given year, and you can consider any year. Okay, in between this interval, you can consider the outside interval also. For example, I need to predict the populations in the year 1940. Okay, so we can also check this approximate value as per this given growth. Okay, similarly we can also predict the answer at 1795. We can also predict the population growth in the year 1795 also. Okay, so this is meaning of interpolations. We can check any intermediate value. This is our intermediate value. Okay, 1898, 1925, 1940, any intermediate value we can compute by using the given tabulated data. Okay, by using given tabulated data. That is meaning of interpolation. And now after that we have two types of data in this case, okay, as a argument of x. So that is the argument x0, x1, x2 up to xn. Okay, so two types of data is that one is the equally spaced data and second is the unequally spaced data. Okay, and in the interpolation theory we'll learn four various methods. Okay, Newton forward interpolations formula. Okay, first one Newton forward interpolations formula. Second is Newton backward interpolations formula. Then after Lagrange interpolations. Okay, and the fourth one is Newton divided difference formula. NFIF, NBIF, that is backward, Lagrange interpolation, and Newton divided difference formula. This four formula will use to predict such answer. Okay, so for the argument x0, x1, x2 up to xn, if it is equally spaced data, what is meaning of equally spaced argument? So here one table is given that just take the first row only. Okay, x argument that is in the form of 4, 6, 8, 10, 12, and so on. Okay, so what does it mean? This is called equally spaced argument. The two consecutive difference, okay, difference between two consecutive values, they are same here. Okay, it is the same. 4, 6 minus 4, 8 minus 6, 10 minus 8, 12 minus 10. This is the same here. Okay, difference is the 2. So this data is called equally spaced data. Okay, in place of that, if I write 1, 2, 3, 4, 5, that is also known as equally spaced data. Okay, and then after if I consider odd number 1, 3, 5, 7, 9, and so on, that is also called equally spaced data. Okay, so for equally spaced data, we'll use the Newton forward and backward formula to predict the answer. And for unequally spaced data, what is meaning of unequally spaced data? The one table is given here for unequally spaced data. What does it mean? Data R is 1, 2, 7, 8. Okay, so check the difference of two consecutive value. 2 minus 1, that is 1 here. That is 7 minus 2, that is a 5. Okay, 8 minus 7, that is 1. So difference is not a same. Okay, here difference is the same. It is a difference between any two consecutive value, that is equal. Okay, and here it is not the same. So that is called unequally spaced data. Okay, any value, any input is given that, and such output are mentioned in this table, and we need to predict one intermediate value output based on this data. Okay, so for this data, for unequally spaced data, we'll apply the Lagrange interpolations and Newton divided difference formula. Okay, and for equally spaced data, we'll use the Newton forward and Newton backward interpolations formula. Okay, so that is the difference between two consecutive values is not the same. Okay, here you can consider any two consecutive value, 2 minus 1, 7 minus 2, 8 minus 7. So difference is not equal. Here difference is equal. Okay, so it is equally spaced, that is unequally spaced data. So here it's given that we can find the interpolations for equally spaced data from the following method, that is Newton forward and Newton backward. And when we apply Newton forward and Newton backward, we'll discuss after that. Okay, for which case we'll use the Newton forward interpolation and for which case we'll use the Newton backward. Okay, first condition, that should be the equally spaced data. Okay, and then after we'll identify conditions when we have to apply Newton forward and with Newton backward. Okay, in this table. So here on same example is given that one arbitrary table, the population of growth in this town given below, estimate the population for 1895. Okay, and here second year is given that 1925, that is in between last interval and that is in between first interval. Okay, so now question is when you have to apply Newton forward. ठीक है, फॉर्मूला हम बाद में देखेंगे, पहले उसकी कंडीशंस let us learn that के when in which case, ठीक है, कौन से केस में आपको न्यूटन फॉरवर्ड अप्लाई करना है, कौन से केस में न्यूटन बैकवर्ड अप्लाई करना है. ठीक है, पहले आपको क्या चेक करना है, चेक दैट द डेटा शुड बी इन इक्वल स्पेस. अगर वो इक्वल स्पेस है तभी ये दो मेथड अप्लाई होगी. ठीक है, इफ इट इज अनइक्वल स्पेस देन वी हैव टू अप्लाई Lagrange and Newton divided difference. So now the data is equal space. You can check the argument, the year value 1890, 1900. The difference is a 10 here. Okay, here it is also 10. That is difference is a 10, and here it is also 10. So it is equally spaced data. Okay, and now if your unknown value क्या है, that is 1895 की वैल्यू आपको डिफाइन करनी है यहाँ पे, that is unknown value. Here 1925 की वैल्यू आपको डिफाइन करनी है. So if the unknown value, if this unknown value, if it is nearer to starting of your tabulated data, the unknown value means 1895 value, if this value is nearer to starting of your tabulated data, then for this case we will use a Newton forward difference formula. Okay, again I repeat that if this value is nearer to starting of your tabulated data, then for this case we can use Newton forward interpolations formula to find a suitable approximate answer. Okay, now how we can check it is nearer to starting of our tabulated data? Okay, so just check this data. This is the central value. Okay, 1910, that is the central value. So this interval is our starting interval, 1890 to 1900, and this interval will be our ending interval. Okay, 1920 to 1930. Clear? So if this unknown value is nearer to starting of your tabulated data, then for this case we will use a Newton forward interpolations formula to predict the value at 1985. We'll use a Newton forward interpolations formula. Okay, any value you can consider. If it is nearer to starting, okay, you can use here 1896, 1895, 1897, 1899. Okay, you can also consider a starting. Okay, before the 1890, you can also consider 1885. Okay, to predict the output of 1885, we'll use the Newton forward interpolation formula. Okay, if this value is nearer to starting of your tabulated data, और जो value है वो किस इंटरवल से नजदीक है, दैट इज नियरर टू स्टार्टिंग ऑफ योर टेबुलेटेड डेटा, स्टार्टिंग में जो वैल्यू उससे और नजदीक है. ठीक है, so we can use the Newton forward interpolations formula to predict the answer. Okay, and if your unknown value is nearer to ending of your tabulated data, okay, now the end of your table, that is interval 1920 to 1930 and so on. So if your unknown value जो आपको predict करनी है उसकी value, ठीक है, by using the formula, so if it is nearer to end, ओके, 1925 है, 1927 है, ठीक है, 1922 है, 1935 है, 1936 है. ठीक है, तो दिस इज नियरर टू एंड ऑफ द टेबल. Okay, nearer to ending of your tabulated data, so we'll use a Newton backward interpolations formula to predict the answer. Okay, that is the difference between Newton forward and Newton backward. You can get one answer, okay, by using any method, but the suitable answer, okay, suitable to the 1895, if it is nearer to starting, then by using Newton forward interpolations formula I will get a suitable approximate answer. Okay, and if it is nearer to end, okay, in this case you can also apply Newton forward, but you will not get suitable answer. Okay, but by using Newton backward reference table will get its suitable value, okay, which in between this range also. Clear? So for ending data we'll use Newton backward interpolations formula, and for starting data we'll use the Newton forward interpolation formula. Is it clear to all? Have you any query in this case? Yeah, is it clear this conditions when you have to apply Newton forward and Newton backward? Have you any doubt, anyone?
Sir, can you repeat it once more?
Okay. See, first we'll check the equal space data. Okay, right now this equal space data we have, for this case we have two cases. We can apply Newton forward and Newton backward. Clear? We can apply Newton forward, otherwise Newton backward. So now in which case we can apply Newton forward, okay, and which case we can apply Newton backward. So now this data are given in this table. Okay, ये data आपके पास है, that is 1890, 1900. These are equally spaced data, and one output is given that, okay, as the population's growth, that is given here in this output. And now you have to predict a value, okay, the populations at 1895. ये आपको find करना है, ठीक है, that is given. Find the populations at 1895 and find the populations at 1925. So if the unknown value, ये unknown value है हमारे लिए, इसकी वैल्यू हमें प्रिडिक्ट करनी है यहाँ पे. ठीक है, हमें यहाँ पे इसकी वैल्यू प्रिडिक्ट करनी है. तो इफ योर अननोन वैल्यू, जो वैल्यू क्वेश्चंस में दी गई है, इफ इट इज नियरर टू स्टार्टिंग ऑफ योर टेबल, ठीक है, स्टार्टिंग वैल्यू मीन्स स्टार्टिंग इंटरवल. स्टार्टिंग इंटरवल कौन सा है? 1890, 190, that is our starting range, starting interval of the table. This is a central 1910, that is a central value. So ये starting interval हुआ, ठीक है, तो ये ending हुआ 1920 to 1930. So if the unknown value is nearer to starting, for this case, we'll use the Newton forward interpolations formula to predict the answer of populations at 1895. Okay, similarly for 1896, 1885, this all are the nearer to starting of the table. Okay, this all unknown value are nearer to starting. So for this case, we'll use the Newton forward. Okay, this case में हम क्या apply करेंगे? Newton forward interpolations formula. If your value is nearer to starting of the interval. And second case, when we apply Newton backward, if your unknown value is nearer to ending, 1925 है, 19222 है, 1922, 1935, 1936, this all value are nearer to starting of the nearer to ending of the interval. Ending interval कौन सा है टेबल में? That is 1920 to 1930. That is the ending interval ending length. Okay, so इफ योर अननोन वैल्यू, ये अननोन वैल्यू है, ये हमें प्रिडिक्ट करनी है इसकी वैल्यू, ठीक है, इसकी पॉपुलेशन हमें प्रिडिक्ट करनी है. तो फॉर दिस केस, ओके, इफ इट इज नियरर टू एंडिंग, देन we'll use the Newton backward interpolations formula. That is the difference.
Sir,
Yes.
sir, if we have a six, one more, 1914, and his people's, so how to find a center in this?
If we add one more value, suppose if we add one more length 1940 and there is one interval 150. Okay, so for this
Yes.
case, you can easily mention that okay, this will be the central interval, that okay, and that will be the ending. Okay, if it is nearer to ending, okay, and if we have 1925 value.
Values 1910 and 1920 both are center.
Yes, that will be our central form. Okay, 1910, 1920, and for this case you can apply if it is nearer to end, ठीक है, और ends के नजदीक है, ठीक है, so you can apply Newton backward, and if it is nearer to start, ठीक है, then you can apply Newton forward.
Okay, sir.
Okay, you will get one approximate answer that, but ठीक, आप कोई भी एक वैल्यू डिफाइन कर लो, यहाँ पे लेट अस टेक 1925 है, so for this case you can use the Newton forward also, you can use the Newton backward also, ठीक है, both the formula you can use that, you will get one answer that is easy, ठीक है, you can easily find one answer there, but now we need a suitable answer as per the value, ठीक है, हम एक suitable answer find कर रहे हैं, तो which formula is suitable for this value, ठीक है, तो ये जो वैल्यू जो है, इफ इट इज नियरर टू स्टार्टिंग ऑफ द टेबल और स्टार्टिंग वैल्यू से नजदीक है, ठीक है, तो आप इस केस में न्यूटन फॉरवर्ड अप्लाई कर सकते हैं, ठीक है, एंड इफ दिस वैल्यू इज नियरर टू एंड, ठीक है, नियरर टू एंडिंग ऑफ योर टेबल, तो फॉर दिस केस यू कैन अप्लाई न्यूटन बैकवर्ड टू प्रिडिक्ट अ suitable approximate answer. Again, I repeat this word. We can find one answer by using any formula. That is, you can use any formula for this value. Okay, forward backward भी use कर सकते हो, forward भी use करते हो, but now we need a suitable answer. So which formula is suitable for this value? That is our point here. Okay, so if it is nearer to starting of the table, then we'll use the Newton forward, and if it is nearer to ending of the table, then it is we'll use the Newton backward. Yeah, is it clear now? Have you any query?
No, sir.
Okay. And after that, let us discuss this simple one, and then after we'll conclude this session. Second one is there for unequally spaced data. Okay, so for this case, we'll apply the Lagrange interpolations. Okay, that is the difference, and Newton divided difference formula. Both are different formula that, okay, there is no any such specific result we have. If it is nearer to starting, then we'll use the Lagrange, and if it is nearer to ending, that we'll use the Newton divide. Okay, you can use, if it is asked for Lagrange, then you can use the Lagrange formula that. And if it is asked for Newton divided, then you have to use the Newton divided difference formula. Okay, both are different things, both are different formulas that. But if it is unequally spaced data, then you have the two choice to derive it answer. Okay, one by using Lagrange interpolation, and second by using the Newton divided difference formula. Okay, and what is meaning of unequally spaced data? Here, check the argument of x. 9 to 11, difference is a 2. Okay, then after 11 to 15, that is difference is a 4. Okay, यहाँ पे difference कौन सा है? 4 का, 2 and 4. First two value, that is difference 2, second two value difference is a 4. So it is unequally spaced data, unequally spaced interval. So now we have to predict 9.3. okay, by using Lagrange interpolations. Otherwise, you can also solve this answer by using Newton divided difference formula. Okay, here we not apply the conditions. It is nearer to ending, nearer to starting, and so on. Okay, that is both are separate formula. Okay, both are different formula. So if it is asked by using a Lagrange interpolation, then we'll solve the answer by using Lagrange formula. And if it is asked by using Newton divided difference formula, then we'll solve this answer by using Newton divided table. Okay, that is two method for unequally spaced data and two method for equally spaced data. Okay, in this interpolation, and here we'll apply such filter. Okay, if the data is nearer to starting, then we'll use a Newton forward case. And if your data is nearer to ending, then we'll apply Newton backward case. Okay, that is the difference in this equally spaced data. So we'll keep up to this, and we'll start this first formula, okay, Newton forward interpolation, in the next lecture.